I'm Rosemary Wang, and I wanted to tell you about how to treat your network like a container, or get really close to it. So you're probably thinking I'm a little crazy. I'm actually a consultant at ThoughtWorks. My official title is Platform and Infrastructure Consultant. I'm not here to sell you something. ThoughtWorks is actually really well known for writing the playbooks on agile methodology, 12-factor cloud-native applications, and over the past couple of years, we've deployed a lot of platforms for a lot of different clients. And most of this came from some information that I found out myself. I'm a jack of all trades, master of none. That's my Twitter handle. Add the 08 to the end of it. DM me, provide feedback. I'd love to hear from you. So I am somewhere between a developer, network engineer, and system administrator. I'm not necessarily an expert in all three of the fields, but I have an interest in it. I have a deep affinity for the network. So I actually saw this hashtag on my Twitter the other day called digital transformation. And ironically, it had nothing to do with digital transformation. It was tagging someone else entirely. But when we talk about digital transformation, we talk quite a bit about platform transformation. So how do you transform your infrastructure into this new wave of cloud technology? Well, when people talk about transforming their infrastructure, they think it's binary. They think you're either really regressive or really automated. And everybody pushes for you to automate everything at one time. Because that's the magical part. That's what all of the unicorn technology companies do, right? No. Digital transformation is a spectrum, and I'm here to tell you that you can't automate everything in your network, and you can't automate everything in your infrastructure either. So why is that? Well, there are actually three types of resources in your infrastructure. There's your compute, storage, and your network. In the compute space, there have been a lot of advances. So you went from your main servers to your VMs to your containers. And containers are what everybody talks about nowadays. Linux containers are taking over the world. And the value add is that they're highly automated, that you can do this motto: build, ship, and run. I'm sure everybody's seen this on someone's website who sells containers. Building, shipping, and running. What do those things mean in the compute space? Well, developers had a lot of struggles creating their applications and creating servers that fit their applications. So to bypass all of that, they built a really easy way to do that. So you can install your dependencies, and you can basically ship it to anybody you want to. So let's say I build a container image. I can give it to my QA, my quality assurance tester, and he or she can actually use that the same way I used it. How do you run it? Well, containers were made to run really quickly. So you can get them up and running really, really quickly, but then you can upgrade them just as quickly. So you just destroy it. There is no such thing as infrastructure. There's just ephemeral pieces of Linux container everywhere. Network's a little bit more complicated. And the reason why is that you tend to have three types of networking. And containers tend to be actually very, very basically an anti-pattern to what the network does. There are 99 problems, and most of them happen to be APIs inconsistent in your network. Your protocols are inconsistent. There are no standards, or if there are standards, they're not fully embraced by everybody. And the result is that you've got some things that are at the regressive part of the spectrum, like your traditional networking. Those are your switches and routers, your load balancers, heavily vendored, very specific protocols. And then you've got something in the middle, which is your dynamic infrastructure. And I call this the software-defined X. You can say software-defined networking, software-defined load balancing, software-defined whatever. Everybody likes adding software-defined to everything now. So that's somewhere in the middle, and that's kind of more automated, but not quite. You still got a lot of vendor lock-in, even if you go to public cloud. You still have to commit to your public cloud provider's networking. And then you've got containers, which were actually driven by a whole new approach. They decided to say, OK, what do developers really want out of their networking? That's something to abstract, right? They shouldn't know what's going on under the covers. They don't want to talk about CIDR blocks. They don't want to talk about load balancing. They just want to talk about what their applications can and can't do. So they automated a lot of that space. The result is that you've got network engineers who focus on the traditional networking, and then you've got developers who focus on container networking. And somewhere in the middle, there's a really big disconnect. There's a really big disconnect because there are so many technologies out there. There are so many vendors. How do you protect yourself from vendor lock-in? Or how do you protect yourself from assuming the risk of an open source tool that you don't know about? Well, the reality is you can't. And in a build, ship, and run for your network, the key part is not about the building, not about the shipping, and not actually about the running. It's about the testing. Everybody's going to be really upset, but sorry, you have to be your own quality assurance for your vendors or your open source technologies. And the reason why is that it's not about automating all of the things. Everybody's seen this meme by now at pretty much any of the tech conferences you go to. No, it's not about automating all of the things because all of those things will change constantly. But what you are in control of as an enterprise is testing all of it because functionally you know what your network's supposed to do. You know what all of the components of your network are supposed to do, whether it be connectivity, service discovery, or security. You are responsible for that. So how do you test all the things? I'm actually setting this up to give you a crash course in how to test your network. And I'm trying to do it really quickly. So if you have any other questions, feel free to reach out to me while we go through this journey. All right, so crash course in testing, the testing pyramid. This is something written by Mike Cohn, who was in the software development space. And it's a little bit abstract for people who have never used it before. The idea is that the software testing pyramid talks about the 4 different types. Back again. Sorry. What happened to this? Sorry. Go back. All right. So your testing pyramid has 4 different types of tests. Your unit, your service contract, your integration, and your end-to-end. This means nothing. This is sort of gibberish sometimes, right? But I actually did my little own cheat sheet because when I talk to developers, they tell me this, and I'm like, I don't know what it means. So your unit tests validate your configuration. They validate the logic, the simple logic. That's it. Your service, your contract tests validate your interaction. So does your input match your output? What do you expect? What's your expected? What's your actual? Your integration tests actually test both things. They confirm that interaction. And your end-to-end, I think, as the real deal. That's the thing where you want to bring up, you want to test everything end to end. The reality is that as you go up the pyramid, the cost in terms of money, in terms of time, in terms of effort to develop increases. So you want to decrease the number of tests as you go up the pyramid. Your end-to-end tests in the software world can take 2, 4, 5 hours to run. In some open source projects, it can even take 2 weeks to run. So you don't want to run too many of those because it's a lot of time. Then at the top of the pyramid is the giant cloud, which is the manual cloud. So these are your tests that are manual. You sit there, you configure them, and then you validate. Those take the most time of all. In the network space, it's funny. I actually talked to a bunch of network operators the other day, too. They drew this. It's a signpost. They said, what's a unit test? What's service contract test? What's an integration test? Well, we have end-to-end tests and like scripts and stuff, right? It's like, yeah, that counts. That counts. So end-to-end tests, and then there's manual at the top, which is this gigantic cloud, doomsday, right? So can you imagine the cost and the amount of time and amount of money you spend just sitting there trying to test everything end-to-end, or even manually? So let's change this signpost into a pyramid in the network space. Let's talk about build. Everybody talks about automating and how do you build your network. I won't cover that because there are a lot of great materials out there by other experts who are better than I am at this. But I'm actually going to talk about testing it. Automation at the very basis of it all is a given, when, then framework. Given I have a component to automate, when some event happens, that's your trigger, and there's some output that's sort of implicit, then the component should be configured. Really simple, given, when, then. That's how you build something, right? You build something because you have a given, you get a trigger, and then you configure it. Very straightforward. Let's take an example in connectivity. Given I have a gateway to my data center, when I create a container or a software-defined network, then I should set up a route from that network to my data center. That's a very common use case for what I hear in most customers that I work with. So what do you do with this? Well, how do you even apply this to building and then subsequently testing it? What do you think about? This is my other cheat sheet for how to do given, whens, thens, and also how I test my network, right? So givens are at the bottom. Those are your unit tests. That's functionally validating the very basic configuration that you have. And I like to think of this as your config or template validation. Use an automation tool, linting program, whatever you want to do. Just check that it's good. Your when is then your testing framework. But that's also something that you do for your service and your contract tests. The idea is that I should know that my output from my trigger is equivalent to the input that I expect. One great example is subnet masks. So one output from a software-defined network might be one format, and then when you try to get it into your switch, it might not accept it. That's happened before too. So your Wang is just evaluating if those things match. Then you've got your integration tests, and that's your then. That's a functional validation. You can use a testing framework for this as well, any testing framework you want, but there's actually an additional part I like, smoke test. Figure out whether or not it actually works. Deploy something, whatever it is, a tool, your favorite VM, your container, just deploy it, try it out, see how it works. And then at the top of it is your given when then. That's when staging or production, if you want to push to production, your production happens. This scripts, behavior-driven development, anything to just fire off that you've created that, and then you can issue your smoke tests. Same exact smoke test you use on your then. So this is sort of my crash course. How do I apply this to the connectivity example? What I like to do is actually when I have a gateway to my data center, I like to use Ansible, and I find a virtual switch image. And I actually run Ansible against that virtual switch image to see if my config even works, right? Sometimes it just doesn't work at all. So once I figured out that that works, that means I can move to my next stage. Let's move to my when and see what happens. I have my public cloud software-defined network that comes out with a CIDR block. I check to make sure it matches what I expect to put into my Ansible playbooks with my Python nose test. Separate framework. Just general perspective on that one. But Python nose test, I can also use that same one to set up that route from my network to my data center. So I can actually use this to fire off the two components I need and just test what happens between the two. Really straightforward. I can also apply my smoke test. I like containers. I've been using a lot of containers lately. But smoke tests are really easy to issue. When you've got a container, you spin them up. You test and see if you can connect to outside, connect within the network. Then you put it all together. You can use behavior-driven development. Python Cucumber is a great behavior-driven development tool set. It's up to you what you want to use. But I like to put my given when thens all together so everybody knows what is going on. So when they see this, they know exactly what I'm testing. They know exactly what I'm trying to approach. So then here's the next problem. How do I ship it after I've tested my build? How do I give it to someone else and they can actually see what it is? For example, how do you, as a network operator or network engineer, pass this to a developer who has no idea what it is and have them do the same exact thing that you did? Well, this is where unit tests are actually pretty handy. Unit tests, which were at the bottom of the pyramid, they are standards and enforcement. Standards and enforcement are probably the two key parts to shipping your network appropriately. For example, service discovery is a big one. Service discovery, you can have a DDI solution, and let's say you have a service or an application that comes up. That's your trigger. Then you should set up an alias and use a certificate for it, right? So URL automation, usually a pretty typical case in public cloud or even in your data center. I like setting the standards first. So I sit down with my network operators, network engineers, security guys. Everybody sits in the room, and we argue for about 2 days over names because people love names. People get obsessive about names. But we can settle on something like service business company XYZ.net. Design principles are another one. Sometimes these are where your experts come in, right? They tell you only use your private domain. No one should be using public domain unless they've gone through some process or use SSL against it. Common templating and formatting. This one is trickier. When you've got developers, they can be very opinionated on what they like to use and what they don't like to use. So sometimes it's great to establish what you're OK with using, what threshold you have in terms of what kind of formatting or code templating you want to do. Then testing development setup. We like containers. I like doing it with my developers because my developers know what to do, but the network engineers can also use it pretty easily too. And it comes with everything installed. So let's say they wanted to run a chef recipe, which is the same as an Ansible playbook, pretty much. You can just run that container and you know what you're looking for. Event triggers. So maybe when a service comes up, you want to fire it off to Slack, you want to fire it to some ticket system. The reality is it doesn't matter as long as it's standardized and as long as you all agree that this is the trigger system you want to use. The reality is that people like to disagree on what triggers actual automation, but everybody, once they sit down and they talk about it, it actually makes it a lot easier. The next is enforcing those standards, and this is actually pretty difficult. In a large enterprise, how do you know that people are actually doing the right thing? Well, quality review. In, let's say, this use case, I want 2 peer reviewers. Maybe one is a developer, one is a network engineer who looks at my stuff and tells me, no, 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 You can't be using that. That doesn't conform to our company XYZ.net. That's company ABC. Linting programs are also pretty helpful. This is something that developers really enjoy to use. Linting programs like Food Critic for Chef help you determine whether or not someone's violated those rules. So I like to declare martial law, and I say, no, you cannot use like YAML files, for example, something like that. Then I can say in my linting program, don't use YAML files. In my version control, everybody needs to learn version control. I'm sorry, I can't tell you not to learn it. You have to learn Git if you haven't already. Sorry. CI/CD is another big framework that everybody loves to talk about. CI/CD is the whole value proposition behind why you want to test your network in the first place, continuous integration and continuous deployment. That's the dream. Maybe you're not quite there yet, but use a framework to at least accomplish half of this so you don't have to sit there and say, I'm testing this, I'm testing this, I'm testing this. A CI/CD framework can help facilitate that. Then the last bit is documentation. And this is something we forget all the time. Document. No one can read your mind. So I find myself documenting every time I talk about these standards or every time I talk to someone or come to an agreement on it. So these are some things that should already be reviewed. The reason why we go through all this is that tests fail when patterns break. I can't tell you the number of times that someone has said, I set up this URL, and now it doesn't work when I push the change to my network. Did you code a static IP to it? Well, yes. Didn't we agree that we didn't want static IPs? Yes. So this discussion does happen quite frequently. Keep to your pattern, because when your tests fail, you know that someone has either broken with that pattern or there's something very wrong with your network underlying infrastructure, right? So tests fail when patterns break. Keep to your patterns. And when you actually do this, your tests will succeed when you do things correctly. It's never about the tests, although sometimes the tests are wrong. So just make sure to keep to your pattern. The last bit is run. So how do you run a network, and what does running even mean? Well, running in the container world is upgrading, scaling, and securing that network. So there are a couple of ways to do this, right? Upgrading your network, a lot of different ways. Scaling your network, probably more different ways than I can count. And securing your network is probably an entirely new talk that I don't have time for. So how do you do this? Well, you test them. Every single time you test this. And you can actually use your tests from your build step to accomplish this too. So I'm going to go through one use case, and that's upgrade. Upgrade is really dependent on your risk appetite and the configuration of your network. So you can do an in-place upgrade if you want. Just remember, there are certain things that you might be risking. But if you have enough resources, try a blue-green. And people think that it's actually a pipe dream. People don't know if it actually is real. You can actually do a blue-green network deployment. So here's how. I'm going to go back to a connectivity use case again. Given I have a container or a software-defined network, when I need to upgrade that network, then I should create a new network with the same configuration and use it, right? Very straightforward. So I'm creating a new network entirely. There's a little star, assumes no IP address affinity, no static IP addresses. I know that pains some people, but this generally only works really, really well if you try to avoid sticking your IPs in one way or the other, unless you're really, really mature with your software-defined networking space. So let's say you have a network orchestrator, you have a compute orchestrator. You've got your compute clusters on your blue network, and now you've deployed a new green network. What do you do with this green network? You run your tests against it, actually. Same tests should apply. Because you've reproduced it so many times, your same tests should apply to your green network. Then you tell your compute orchestrator, so go tell your compute team, can you deploy a cluster for me? Use this as a canary. Use this to test if something's actually working on your network. Then you can actually start telling your compute orchestrator, deploy half my clusters on blue and half my clusters on green. It's a good way to tell you whether or not something's actually working. You gradually move over until you have enough confidence that you can go 100% of your compute clusters on this green network. And eventually you can take away your blue one. And the cycle continues. So this is a really simplistic understanding of blue-green. There are a lot of bits and pieces that you have to figure out too. But it's actually a lot closer than we think. So at the end of the day, networking is challenging. I'm not going to tell you it's not. I'm not a network expert, and I find it challenging, even working with developers, even working with great network engineers behind me. But invest in tests. Take the time to do it. Because actually, it doesn't matter what vendor or what open source tool you use. You can still use the same tests if you've written them appropriately. And patterns and standards are useful. This is something that most people do in their organizations, but they don't necessarily realize the impact of it. Keep to a pattern and keep to a standard. The last bit is, how do you get involved? This is a big question, because how do you have the skill set to even get involved in the first place? Hack. There are a lot of examples out there. A lot of examples. Read through GitHub. Coding is probably like 80% reading, and then 18% repurposing, and 2% writing original code. So at the end of the day, hack, read examples. Search querying. This is tricky, because sometimes it might not come out the way you expect, but try to do blank testing framework. Be specific as possible. If you do blank testing framework to at least give you an idea of what testing frameworks are out there and can help you, they actually come up with some pretty useful pages. So I actually tested this with like multiple variants. So Python, Golang, whatever you can choose, it does come up with the right search terms. The last bit, befriend a QA or dev. I can tell you the number of times that someone's taught me something by sitting next to me and telling me, no, that's not how you develop. And then they correct me. So my best ally is a developer who taught me how to unit test, who taught me all of these things, right? So pair with someone. Reach out in your organization. Reach out to someone in the open source community. They'll usually give you a better idea. And once you've actually done that, then maybe you can teach me something. Thank you. And I'd like to open the floor for questions if we have time. Questions?
What questions do we have for our first lovely speaker? I know there's got to be one. We got one.
Yes.
Is your slide deck going to be available somewhere?
Yeah, the question was, is my slide deck going to be available somewhere? Sorry, I might sound repetitive. It's because I have to do this for the recording. Yes, my slide deck will be posted, I don't know if through NINOG or through NINOG.
Posted on our site.
Okay.
So, in all of your adventures in the text, have you ever discovered the following challenge? That this can be a complete, true network model that you can place in network configuration in the network state that is using the source.
Good question. So yes. The question is, have I ever come across a complete network model that reflects a source of truth about my network configuration? The reality is no. Everybody has talked about it. Everybody has asked about it. Most of the time, it's a multi-vendor landscape. So sadly, I haven't found one. My dream is to kind of actually have all the container networking standards and all of the software-defined networking standards and all of the traditional networking standards partner, but that's a dream. Unfortunately, no. Unless you stick with one vendor, you're not going to find one right now.